Hello and welcome. In this tutorial we're going to wire and read readings from the MPU 6050 gyro accelerometer. So a gyroscope is a device that detects tilt and turning. An accelerometer is a device that detects force. In my mind, accelerometers are a lot more interesting. So essentially an accelerometer would be able to, if you placed it still, would be able to detect gravity and the absence of gravity for once. So the idea is I'm going to place this gyro accelerometer on this cube, and we're going to turn it at different angles, and we're going to see this actually in effect. You're going to see how gravity is distributed if this is tilted and how it's distributed if it's still. But first of all, we're looking at a fairly simple circuit diagram here, but we're looking at two different libraries. DFRobot comes up with this example code on its wiki. I am going to do something a bit simpler. So I'm not going to use the wire.h library. So we're going to use the I2C dev and the MPU 6050. Essentially, those are the same libraries. I2C devlib is a family of libraries for various accelerometers, MPU 6050 being just one of them. And very soon the support is coming for multiple platforms. At the moment, they only work with Arduino. So what you want to do if you don't have these already is go to this wiki and install from this zip the library. So you're going to go into Tools, Sketch, Include Library, Add Zip Library, and browse to where those were downloaded. So let's get to the schematic. Pretty straightforward. I've got cables that are almost color-coded with the image there. The red cable is going to go into the 5E. The black is going to go into GND. The green is going to go into 4, and the white is going to go into 5. So I'll just go in so you see it. VIN to 5E, G to GND. SDA is the green one. That's going to go into number 4, and SCL into number 5. Then I'm just going to place this on this cube so that we can actually more easily detect angles. Put this cube down. Excellent. All right, so let's write some simple code. So as I said already, the I2C dev library is the first one, and then there is actually a specific MPU 6050 library, which looks like this MPU 6050.h, and that needs to be hashtag include. You can't put these on the same line. For some reason, I tried to compress the code earlier, and then you essentially set the device for the I2C dev to MPU 6050, and this is the code that you write: MPU 6050 accel gyro plunk. Then you write a 16-bit integer, and you create essentially all of them for the accelerometer and gyroscope. So AX, AY, AZ. So that's the 3 for the accelerometer, and then GX, GY, GZ. Next up, we are good to go with the setup. We're going to serial.begin. We'll try 9600, and we're gonna do Excel gyro. dot initialize. Okay, that's that. And with one command, these 6 variables are all going to be supplied. So that's Accel gyro dot get motion, and then at ax comma at ay az x y z gx gy gz. So right now, we should, in theory, have values that we could just simply serial dot print ax, for example, and we can delay a second. This should, in theory, work. Gonna save it as a random sketch. Initialize. Initialize. I think there's a 6 going in here. Oh, 9,600. Yay! So we can put that into ln, and so there you have it. So we should be able to change these values. Right. And I think a much fuller picture will happen if we actually print out all 3. So serial, accelerometer x, and then ax. We can print all of them and make a bit of a shorter delay. And make that just 100. And maybe serial.print ln. So let's see how that looks like. And okay, get rid of the auto scroll. So as you can see, the Z, that being the gravity, the Z is like 15,000 something. So I want to get this primed so that you see, I'll make this at like 0.3 of a second. Watch this. So Z, you're looking at it, 15,000. We're going to turn this around. Now Z is nothing but Y is minus 16,000. If we put it this way, Y is 16,000. which leaves x to be this way. So right now x is minus 15 and x is plus 16. And if we shake it, well, obviously the forces get distributed differently. So that is the amazing accelerometer sensor. We can do the same. I guess we can just copy and paste this to get the gyroscope. So gyroscope. Gyroscope X, Y, Z and G, X, G, Y, G, Z. And the gyroscope actually responds to turning. It's kind of hard to follow this, but if you turn it, you're going to see the gyroscope values change. So in the next tutorial, I will look at putting in 3 LEDs and playing a little bit with the accelerometer. We may have to change the camera setup to zoom out a little, but I shall see you then.